Hi everyone, I'm Rudrani. Welcome back to Encrypt Coding. Don't forget to like, share, and subscribe to stay updated on our latest videos. This video is a continuation of the string functions part 1. So today we'll be mainly discussing 8 string functions. Up first, we have the compare to function, which basically does a comparison of two strings with reference to their ASCII values. And the output of this function is always an integer. So here we have a sample code. S is equal to hello and st is equal to hello with a capital H. And here S is being compared to st, and that's the reason S is known as a calling string and st is known as a parameter string because it's present in this function as a parameter. So this is the syntax. So what does this function actually do? For now, let's just focus on strings with same lengths. It takes the first characters of both strings, let's call them C1 and P1. Now, every character in Java has an ASCII value, which you can see in this image right here. And do note that this function is case sensitive, so uppercase and lowercase letters would have different ASCII values. For example, if you take A, capital A has an ASCII value of 65, while small a has an ASCII value of 97. The computer takes the ASCII values of C1 and P1 and subtracts P1 from C1. If the resulting value is 0, which happens when the characters are same, this process repeats itself with the next character of both strings. It continues until the value of two given characters are something other than 0. But in some cases, for example, if the strings are identical, then the output would always be 0, right? In that case, the final value returned by the function would also be 0. So we can use this to determine if one string is lexicographically greater, lesser, or equal to the parameter string. If the output is a positive number, then the calling string is greater than the parameter string. If the output is a negative number, then the calling string is lesser than the parameter string. And as I mentioned before, if the output is 0, then the calling string is equal to the parameter string, meaning the two strings are identical. Alright, till now we've been discussing how it works if the strings are equal in length, right? But what happens if the strings are not? Take a look at the example. Here, ST's length is greater than that of S. So after one point, there would be nothing to compare the characters of ST with. What do you think happens? Pause the video and give it a try. So if the computer keeps comparing until the characters of either string end and the subtraction of their ASCII values results in 0, then the length of the parameter string is subtracted from the length of the calling string. So in this case, since the letters are same till string s ends, we just subtract s dot length minus st dot length, which is 7 minus 14 or minus 7. So minus 7 would be the output of this code snippet. So we'll just try code in BlueJ. Here S and ST are the same except that ST has two exclamation points at the end. So if we run this code, the answer would be 2 because S has two extra characters, or you can say that the difference in the length of the strings is 2. Right, so I wrote a code that mimics what the compare to function does, which will help you understand that a little better. So this is the code. It's not inside a function, but it gives you the same result as the function when you input s and st values. And we even have the actual function at the end just to confirm if my code gives the correct answer. So that's that. And here we're just declaring our strings s and st. Then we'll be requiring I to run our while loop, and x is equal to math.min of s.length and st.length. So I've used a math function here actually, and this function basically returns the smaller value of the two. What we're trying to store in x is the length of the shorter string, and we also have a boolean check variable, and I'll come to why we need that later. So while I is less than x, what we're trying to do in this while loop is check if the characters in the smaller string or the shorter string is the same as the corresponding ones in the longer string. So int c1 is equal to s dot caret of I. So this is basically just going to store the ASCII value of the character of index position I. And same for P1. I do want to point out that there's an implicit conversion going on here from char to int, because this character function returns a character value, and char variables uh, take up 2 bytes of memory while integer ones take up 4, right? So the compiler at the time of compilation just automatically converts it from char to int. So we get the corresponding ASCII values of that. Here we're going to check if C1 minus P1 is not equal to 0. So if they are not, then ideally the difference should be just displayed, and that should be the end, right? So here we are displaying the difference, and where check is becoming false. So this condition won't be satisfied when it comes out of the loop, and then we just break away from the while loop, and that's the end. Okay, so I just want to consider three scenarios here, um, and just do kind of a like a dry run with you guys. So the first one would be where S is equal to ABBA and ST is equal to ABBA with a capital A. And X would actually just equal to 4, because I mean both the strings are of same length, and that's 4. So this doesn't really matter here. And Boolean check is equal to true. So the first time the while loop runs, I is 0. So 0 is less than 4, check. C1 would equal to the ASCII value of character at index position 0, or this one right here. And if you recall, the ASCII value of this is 97, so this will be 97, and P1 would be ASCII value of this, and that's 65. So here we're checking if 97 minus 65 is not equal to 0. And obviously that would be correct, because the difference is 32. So 32 is not equal to 0. So it would print out 32, and then check would become false, and then it would just come out of the while loop. Here again, it's checking if check is equal to true, and we know it's not because it's already been changed here. So this won't be executed, and we'll have the final value of the function. So let's just run that once. And we were right. The answer would be 32 in this case. So scenario 2 would be when the strings are exactly the same. So I said that when the strings are same, the output would just be 0, right? And I'll tell you how. So every time the while loop runs, okay, it won't really, it'll be pretty simple, because C1 would equal to P1 because they're the same characters. And so this will always be true. Sorry, I mean this will always be false, because C1 minus P1 would equal to 0. So this will never be executed, and it will just continuously keep going for I++. And Boolean check would also remain true. So when I is equal to 3 and this loop would be run, we go to the else statement because obviously this will equal to 0. So this is not satisfied. So I plus plus would equal to 4, and then the next time it goes to this statement, 4 is less than 4. That would be wrong. So it'll come out of the while loop, and then it's going to check if check is equal to true, and it would be because this has never been executed. So then we just print the difference of lengths. So, and that actually would be 0 because they're the exact same thing. So let's run that, and yeah, it's 0. So that's that. And scenario 3 would be when this maybe like has an extra 1 2 3, so this will be shorter obviously. So x would equal to the length of this one, or 4. So the first 4 times it would actually run pretty smoothly. It would just constantly keep going to this statement because the characters are same, so it will always equal to 0. And then when I is equal to 4, like the last time, it would just come out of the loop. And again, Boolean check would also remain true because it hasn't gone through this part of the code. So here, this will also be satisfied. And again, it'll just print the lengths, or it'll print the difference of lengths. So the length of S is 4 and ST is 7. 1, 2, 3, 4, 5, 6, 7. So it'll just print 4 minus 7. So the answer should be minus 3, right? So let's run that one as well. And there we have it. It's minus 3. So I hope that helped you understand this function better. Now, moving on to compare to ignore case. This one's actually pretty self-explanatory. It's the same function as compare to, except that the compare to function is a case-sensitive one, while this one is not. Next, we have the index of function, which returns the index position or value of the first occurrence of a particular character or substring inside a string. So, for example, here we're looking for the index position of n in the string s. And the first time n occurs in s is here, or index position 1. So that's the answer for the first example. And now there's a variation of this function. It's actually an overloaded function, which you'll be learning about in later videos. But for now, here we've added a 4 after the n. So we're still looking for the same character n, but only starting from the fourth index position. So it skips anything it finds before index value 4. Do note that if you don't specify a number, it will search for it from index 0 or the first character. So for the second one, the answer would be 12, as after index 4, it appears at index 12. The third and fourth are similar examples to their previous ones, but the main difference is that I've used string instead of char. And in the fourth example, we are looking for the substring crypt starting from index position 5. So starting from 0, 1, 2, 3, 4, 5. And as you can see, there is no substring that matches with the one we are looking for. So in a case like this, the final output is minus 1. It's always minus 1 if the character or substring isn't found in our string. So we'll just quickly see a code of this in BlueJ. So here S is equal to encrypt coding, and we are looking for the index value of the substring coding starting from index position 9. So starting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's kind of like the similar example because from the position we're looking for, there is no substring that would match with the one we're looking for. So in this case, the output would be -1. So moving on to last index of, um, yeah, this one finds the index position of the last occurrence of a character or substring. So in the first example, we look for the last occurrence of 3 in S, and that is here, or index value 10. The second one is a similar example, but here we use a substring. So 1, 2, 3 starts at this index, which is 7. So that's the answer for this. And now the third and fourth example. Here, when you write 5, um, it looks for the last occurrence of 3 from index positions 0 to 5. And similarly for this, it looks for the substring 23 from index positions 0 to 3. Now, this concept was kind of difficult for me to understand, so I wrote myself a code that mimics this function, and I hope this helps you understand it better. So here we're trying to extract the last index value of the character T in the string Taylor Swift without using the function. But I've mentioned the function here at the end just to kind of double check if the code I've written is correct. So if this value and the value my code gives is the same, then this code is accurate. Right, so here I've declared my variables. Car C is equal to T, string S is equal to Taylor Swift, and Boolean check is equal to true. The check variable kind of serves the same purpose as the one in the previous code. I'm referring to compare to. Um, so I'll explain that a little further later. So here we have a for loop. Int I is equal to s dot length minus 1, I is greater than equal to 0, and I minus minus. And inside we have a if construct. C is equal to s dot caret of I. And so what the purpose of this for loop is to just check if this character is the same as any of these characters in this string. And if there's a match, then the index value of that character is printed. And then check becomes false because we've already found a match. So it should not, this has to be false when it comes out of the loop, otherwise it will also print this. So we break away from the loop. And one question you guys might have is that why the -1, right? Why not just s dot length? That's it. The -1 is actually pretty important here, because if we don't have it, then the first time the loop runs, I would equal to 12, as that's the length of the string. And then here we're going to extract the character at index position 12 of this string. And if you can recall, index positions are from 0 to the length of the string -1. So this would definitely give you a runtime error. So that's why that's very crucial. Um, if a value, if that match has not been found, for example, if C is equal to something like 6, which is not in the string, then how the check variable helps here is that it's true at the start, right? So because we never find a match, this is never true, and it doesn't reach this part of the code. So check would always remain true, and when it comes out, we check here if this is true, and it would be true because it didn't go through this. And then it would just print -1. So that would mean that it hasn't been found. So it conveys the right information. And so in going back to our old example, in this case, the output would be the last index value of t, right? So that would be the ASCII value of this. Sorry, not the ASCII value, the index position of this. And that's 11, I think. Yeah. So let's check that one. Right. So we were right on that one. It's 11. Um, I also wanted to talk about a variation of this code. If we put a number after this, then we basically just have another variable here. Int a is equal to 4, and here I've just inputted the same thing. So we just make one tiny change to the code, and it would run perfectly fine. So instead of s dot length minus 1, we say I is equal to a. So the loop would run from 4 to 0, and so this will also serve our purpose because now we're looking for the string, the character t in this string, but from index positions 0 to 4. And of course, it will check it backwards because this is the last index value. Um, so yeah, if it finds a match, it prints the index position, and this part's kind of the same. And this would also be very useful here. Um, so in this case, the output should technically be 0 because we're looking for it from index positions 0 to 4, and here the only occurrence of t is here, and that's at position 0. So let's run that one. Right, so it is 0. So we were correct with that one too. Um, so that's that. So moving on to our next function, um, we have the string dot value of function. Just a second. Right. So this one basically just converts literals of any data type into a string literal. As you can see in the examples below, using this you can convert any data type, be it integral, fractional, boolean, or character, into a string. You can even convert arrays into a string. This is a character array called data, which comprises of the letters of the word hello. And we can convert this into a string in two ways, using the value of method or by writing string s is equal to new string, open brackets, data, close brackets. And the result for both would be s is equal to hello. However, these two only work for arrays of char data type. So moving on to the replace function, this simply just replaces all occurrences of a particular character or substring by another. Here are some examples. So in this, E gets replaced by an ampersand sign, and this would then be the output. Second one is the same thing but with strings. So wherever there's an HE, that would get replaced by an HA, and this would be the output for that. One point to remember is that you can't mix and match the string and the char data type. It either has to be both strings or both char. Next up, we have the trim function. This basically just removes any extra spaces before the first and last character, if there are any. It does not remove the spaces in between characters. So in the example below, there are these extra spaces before the first character and after the last character, right? So after this line of code, S would equal to hello there without these extra spaces. Moving on to the concat function, this one's actually pretty self-explanatory. It joins two strings as shown in the example below. Do note that it doesn't change the value of either string. Up next, we have the plus operator, which it's not a function, but this one joins strings with literals of any data type. It's actually another alternative of the value of function, because you can just say string s is equal to open and close double quotes plus whichever value you want to convert to a string. So this this would be the correct way of writing these, and these would be wrong. We can also use it while printing two strings as shown in the example below, this one right here. So that concludes today's video. Thank you for listening. I hope you liked the video, and if you did, don't forget to like, comment, and share this. Feel free to post any questions in the comment section below or send us a mail at the email ID in the description. Subscribe to our channel for more content. Thank you.